Walk through these doors, and 20 minutes later, you're standing barefoot on a real beach. You're still inside the same building. In fact, you've never left it. This is the largest building on Earth. Inside are hotels, shopping streets, a water park, and something nobody expects to find under a roof, a real beach where waves roll onto actual sand beneath a sunset that never ends. Every bit of it exists inside the world's largest building. China didn't just build a bigger shopping mall. They built an entire world indoors. But the real question isn't how they fit a beach inside a building. It's why they decided to in the first place. This is the New Century Global Center in Chengdu. And before you picture some oversized shopping mall with a mural on the ceiling, understand what you're actually looking at. This one building could swallow 20 Sydney Opera houses. It could hide 3 Pentagons inside it and still have room left over. Walk from one end to the other, and you're covering roughly the length of 5 football fields laid end to end. And somewhere inside that footprint, engineers built a beach. Just closing a footprint that size in roughly 3 years meant steel and concrete arriving around the clock, because no staging area on site could hold more than a fraction of what one building needed at once. Before anyone got near a beach, the challenge was simply feeding a structure this size fast enough to keep it from stalling under its own scale. Not a pool with a sand-colored floor, an actual artificial coastline, stretching hundreds of meters, with a wave pool large enough to be considered one of the biggest indoor bodies of water on Earth. A building did that. Not a stadium roof, not a park, one continuous structure holding an ocean indoors. Before this building existed, the record for largest floor area under one roof belonged to an airport terminal in Dubai. Chengdu didn't just beat that number, it buried it. There's a separate record this building doesn't hold, which makes it stranger, not smaller. Boeing's aircraft plant in Everett, Washington still wins on raw volume, built to swallow entire jumbo jets whole. What this building did instead was point that same industrial-scale ambition at something no factory ever had to attempt, convincing the human body it's standing on a beach. Here's the part that should stop you. None of this was supposed to be possible, not at this scale. To understand why, you have to look up at the roof. A roof over a beach sounds simple. It isn't. To cover a space this size without a single interior support column, engineers needed a steel structure spanning close to 200 meters in one direction and over 400 in the other. That's not a roof anymore. That's closer to the scale of a suspension bridge laid flat, arched into a curve, and asked to hold itself up over open space where thousands of people would be swimming underneath it. The glazed section of that roof alone covers more than 45,000 square meters, a window bigger than several football stadiums, held up by steel instead of walls. And this building sits in a province that lived through a catastrophic earthquake in 2008, one that leveled towns not far away. Every engineer on this roof knew a miscalculation wouldn't just blow the budget. It would decide whether the structure over thousands of people stayed standing when the ground moved. The answer was to design the frame to flex under a quake instead of fighting it. Joints built to let an earthquake's energy pass through the building rather than get caught inside it. A structure like that has to solve 2 contradictory problems at once. It needs to be light enough that it doesn't collapse under its own weight across that span. And it needs to be strong enough to survive wind, seismic movement, and decades of stress in a region where earthquakes are a real design consideration. Engineers get one of those 2 things by adding steel. They get the other by removing it. For a while, that tension looked like it might cap how big a single-span indoor space could ever be. The solution came from treating the roof less like a lid and more like a shell. A curved gull-wing steel and glass structure that distributes load the way an eggshell does, instead of relying on brute mass to hold itself together. It worked. The roof went up. And that's when the second problem showed up, one nobody could solve with more steel. Raising it meant lifting massive steel truss sections before most of the walls beneath them even existed. Engineers effectively built a floating roof first, then grew the rest of the building upward to meet it. Get that sequence wrong, even briefly, and unsupported steel that size becomes a hazard hanging over an empty site, not a shelter over one. Glass roofs let light in. That's the whole point of putting sand and water under one. But Chengdu's sky isn't reliably blue. The city sits in a basin that traps haze and cloud cover for long stretches of the year. Build your entire beach experience around real sunlight pouring through that roof, and on a bad week, your multi-billion-dollar indoor ocean looks like a gray warehouse with damp sand in it. So the engineers stopped relying on the sky. They installed one of the largest LED screens ever built into a ceiling, a synthetic horizon over 100 meters long, running an endless loop of sunrise, midday glare, and sunset, regardless of what the actual sky outside is doing. The beach doesn't wait for weather anymore. It manufactures its own. But manufacturing weather creates a new problem, and this one is about numbers, not light. To keep sand, swimmers, and a wave pool comfortable year-round, the interior has to be locked at a steady temperature and humidity. No matter what Chengdu is doing outside, whether that's a humid summer or a damp Sichuan winter, that means running climate control across more floor space than most airports occupy, continuously, forever, just to keep one indoor beach feeling like a beach. In practice, that's a second building nobody sees, ducts, chillers, and pumps running behind the walls, working non-stop so the illusion in front of every visitor never breaks. The bigger the illusion, the bigger the machine required to sustain it. Every single day, it stays open. And the building wasn't even finished being difficult yet, because underneath all of this, the roof, the beach, the sunset screen, sits a working metro line. The complex was built directly on top of an active transit station. Construction crews weren't pouring foundations into empty ground. They were building one of the largest enclosed structures on the planet directly above vibrating rail infrastructure that the city still needed to keep running. Get the isolation wrong, and every passing train sends a shiver through a roof that's already stretched to its structural limit. The fix was to separate the building's foundations from the rail bed beneath it, with dampening joints that absorb a train's vibration before it ever reaches the structure above. A technique usually reserved for protecting one sensitive machine, not an entire building the size of a small town. That vibration problem only got harder once guest towers went up directly around the pool, stacked several stories high, adding thousands of tons of extra load right at the edges of an already maxed-out roof. The isolation systems weren't just protecting a roof anymore. They were protecting one building carrying an entire vertical city on top of a beach, on top of a subway. Then, just as the building neared completion, a corruption investigation swept through the regional government behind it, delaying the grand opening that had been timed around a major international summit. Whatever was happening in the meetings upstairs, the structure itself was already finished, sealed, powered, waiting for permission to open. It opened anyway in the summer of 2013 after roughly 3 years of construction, at an estimated cost of $8 to $10 billion, for one continuous structure holding a beach, a wave pool, hotels, and a sunset that never actually sets. And here's where the story stops being about concrete and steel and starts being about something harder to engineer: keeping it all running. A building this size doesn't just need to be built once. It needs to be powered, staffed, and filled every single day for decades. Reports on the complex in the years since have pointed to a familiar problem in China's building boom: vast retail space that doesn't always match the flow of paying customers, and energy bills that don't shrink just because a mall is quieter than planned. The hardest part of building the world's biggest indoor beach may not have been getting it built at all. It may be making sure it never has a reason to go dark. As of the mid-2020s, the beach, the ice rink, and the hotels are all still running inside it. Proof the building is still winning the argument it started back in 2013. Other developers across China have chased record-sized malls since, but none have matched this one specific combination: a real wave pool, a roof engineered to survive an earthquake, and a foundation isolated from a subway, all inside a single number, 1.76 million square meters. Because that's the real trade this building made. It solved gravity, light, climate, and vibration one problem at a time. And in exchange, it took on a permanent daily obligation to keep an artificial world alive, whether the crowds show up or not. So if a city can manufacture its own sun, its own coastline, and its own weather under one roof, what happens the day it decides that illusion isn't worth the electricity bill anymore? If you had to keep an artificial beach running forever, what would you cut first? The sunset, the waves, or the crowd?